This is the start of the Mercedes production process at the Tuscaloosa plant in the United States. So the question is, whether cars made by factory workers in the United States meet the same quality standards as those carrying the prestigious Made in Germany label. German-built vehicles are often known for having very precise panel alignment, high-quality interior finishing, and consistent build quality. Right now, you're watching the start of production of the facelifted 2026 Mercedes-Benz GLE and Mercedes-Benz GLS models. This is how car body gets multiple ultra-thin layers of paint, applied by robots in perfect sync for a flawless finish. A large part of the painting process is carried out by industrial robots moving in perfect synchronization, with robotic arms precisely controlling spray angles to ensure even coverage and consistent, repeatable quality. In addition to human inspection, advanced camera and sensor systems scan the surface in real time, detecting imperfections that are difficult for the human eye to see and automatically flagging specific areas for further review. These tunnels are designed to reveal even the smallest surface imperfections that would be difficult to see under normal lighting. As the car body slowly moves through the bright, uniform LED light, inspectors and automated vision systems check the paint for issues such as dust particles, uneven coverage, orange peel texture, or micro scratches. Approximately 350,000 Mercedes-Benz vehicles are sold in the United States each year, with the GLE and GLS models accounting for about 75,000 of those sales annually. In the U.S. luxury car market, Mercedes-Benz is highly popular and ranks just behind BMW. Right now, inside this Tuscaloosa plant, the Mercedes EQS chassis frame and its advanced battery pack are assembled, forming the foundation of Mercedes' all-electric luxury SUV. Originally, the Tuscaloosa plant was dedicated solely to producing combustion engine SUVs. However, since 2022, it has undergone a major transformation, expanding its production to include Mercedes EQ electric models such as the EQS EQE and the ultra-luxury Mercedes-Maybach EQS. Inside this factory, more than 6,000 Mercedes employees work, with the majority of them working directly on this main assembly line. As you can see here, the factory workers are performing individual tasks in well-coordinated teams. At each workstation, there are 2 to 5 workers, with one of them responsible for ensuring the quality of the work performed. Now the chassis frame with the battery pack is joined with the upper body of the vehicle. This process has long been known in the automotive industry as the marriage. A crane lowers the body of the car while the chassis is lifted from below, as a factory worker carefully supervises the process to ensure everything connects properly. The operation is supervised by skilled technicians who monitor every step, ensuring that all electrical, structural, and safety connections lock together correctly. This factory is highly flexible and can quickly adjust its production lines based on changing demand. In the vehicle manufacturing process, a large portion of the work still has to be performed by human workers. This typically includes tasks such as tightening bolts, connecting components, and routing electrical wiring. For these small and precise operations, humans are still far better suited than programmable robots. The EQS is a newer model and part of Mercedes' expanding electric lineup, currently selling in lower volumes, though it has strong growth potential as EV adoption increases. Meanwhile, the GLE and GLS remain the more popular mainstream luxury SUVs in the U.S., largely due to established demand and consumer preferences. Around 2/3 of all vehicles built in Tuscaloosa are exported worldwide, including EQS shipped to Europe, Asia, and the Middle East. If an issue is detected, the EQS battery pack can be quickly removed and replaced at the factory before the vehicle leaves the production line. Before the front grille itself is installed, these workers first attach a mounting bracket and screw in a number of components. An AGV then delivers the vehicle's front grille at precisely the scheduled time. This is how the massive Mercedes front grille is carefully positioned, snapped into place, and securely bolted on by 2 workers. Working together, they ensure the grille is perfectly aligned with the front of the vehicle before tightening the fasteners that hold it firmly in place. In just a few seconds, the illuminated Mercedes front emblem is securely fitted, giving the vehicle its unmistakable brand identity. As many as 13,000 parts are installed in a line more than half a mile long. The doors are temporarily removed to create space to work. Interior components such as electrical wiring and the headliner are installed first, followed by the engine, braking system, and other underbody components. Next come the bumpers, tires, seats, and finally the windshield and rear glass. As you can see right now, workers are installing the front grille on Mercedes models in a highly precise way, regardless of the model or production year. In Mercedes U.S. factories, they aim to maintain a very high level of professionalism, unlike Toyota or Ford. Factory workers wear branded company uniforms, as well as safety glasses and gloves. Production is inspired by Germany's ultra-modern Factory 56, featuring minimal fixed conveyor systems, modular assembly areas, and extensive use of automation and data-driven quality control. Even though it feels fast, each Mercedes in Alabama is part of a continuous 24-hour production flow. It enters the line in the morning and can leave as a completed vehicle the next day. Mercedes focuses on flexible luxury production, with a high level of customization and premium craftsmanship, while Toyota is known for ultra-efficient mass production, strong standardization, and maximum consistency across its vehicles. The seats are wrapped in a protective plastic film during installation inside the vehicle. Workers must always be careful not to damage the car before it is fully completed. Right now, you are watching a factory worker use a manipulator arm to install the entire front dashboard at once. Now, rubber protective components and interior trim are being carefully installed on the Mercedes, adding both protection and refinement to the cabin. This task is also always performed by human workers, as robots are not well suited for this type of work. In this case, human labor is more efficient and cost-effective. At the Mercedes-Benz Tuscaloosa plant, automated guided vehicles are driverless transport robots that move components between different production stations. By automating internal logistics, AGVs reduce delays, minimize manual handling, and help maintain a steady production flow. This factory worker prepares the area for wheel installation, ensuring everything is properly aligned. A robotic manipulator arm then precisely mounts each wheel and automatically tightens all the bolts with consistent torque and precision. After the quick installation of all 4 wheels, only the Mercedes emblem and model designation remain to be fitted. These chrome elements are typically clipped on or glued in place, completing the vehicle, which is now ready to hit American roads and highways. Once these vehicles are fully assembled, inspectors carefully verify that all correct parts have been installed. They then inspect the exterior for any scratches or dents, followed by a detailed check of lighting systems, gauges, and any unusual noises. The accelerator and brake pedals are also tested for proper response, along with a final inspection for any oil leaks. The Quality Control Division serves as the final line of defense, ensuring that every car meets strict standards. Quality inspectors are highly trained professionals who undergo specialized education and certification to perform inspections within a set time frame. They are trained to both see and feel extremely fine tolerances, down to a gap of just 0.1 millimeters between body panels. Drop a comment and let me know what your experience has been with Mercedes build quality from this U.S. plant. And now, the vehicles are started for the first time and immediately driven to the test track located right next to the production hall. Right now, you are watching the subassembly of the entire dashboard of the 6th generation Mercedes-Benz S-Class. This generation was produced from June 2013 to September 2020 and carries the internal designation W222. During this period, more than 550,000 of these global flagship luxury sedans were produced. The largest single market for this model was China, which accounted for about 1/3 of all S-Class sales during this generation, followed by the U.S. and Germany. The core assembly and engineering hub for the W222 was the Sindelfingen plant in Germany. Right now, you are watching how workers in 2015 worked on the underside of the car, which was rotated onto its side using a massive manipulator arm. During peak production periods, about 250 vehicles rolled off the assembly lines each day, and the facility employed tens of thousands of workers focused on premium and luxury vehicles. Each car effectively had a digital blueprint on the assembly line, allowing hundreds of possible configurations to be assembled without mistakes. Many areas, especially interior trim, wood inlays, and leather stitching, were hand-finished by skilled technicians. Right now, you are watching a production process called the marriage. The marriage is the process where the car's major assemblies, like the car body and the drivetrain, are brought together and joined. It's called marriage because two main components are united to become a complete vehicle structure. Panels, doors, and hood gaps were meticulously measured. Mercedes aimed for sub-millimeter accuracy, making the W222 feel perfectly built when you opened a door. Some W222 with this advanced suspension system were calibrated individually on the production line. Each car's sensors and hydraulics were tuned for optimal ride. As you can see right now, the front grille of this 6th generation S-Class was assembled with the help of a robotic arm. While hand craftsmanship was crucial, robots handled painting, welding, and heavy assembly tasks, ensuring consistency across thousands of vehicles. This S-Class was offered with a wide range of engines, including hybrid and plug-in hybrid options, as well as petrol and diesel engines ranging from 4-cylinder units for select markets to powerful V8 and V12, including AMG performance variants. Right now, you are watching how doors were assembled using a manipulator arm. This allowed Mercedes factory workers to guide the doors into position without having to hold their full weight. Doors are installed this way, even today. The 6th generation was one of the best-selling luxury sedans in the world during its lifetime. Strong demand in China helped the model achieve impressive production figures and maintain the S-Class's dominance in the luxury market. With its extensive use of leather, wood, and premium metals, The W222 set the benchmark for quality, comfort, and technological integration. Features like rear seat entertainment, executive seating packages, and night vision assist turned it into more of an owner's limousine than just a car. The 2017 facelift refreshed the styling and introduced improved efficiency and technology features, representing a mid-cycle high point for the model before the transition to the newer W223 generation. Now, this quality inspector will check all functions from the driver's perspective. This is how the four-cylinder engine is crafted at the heart of powertrain production, inside the Untertürkheim plant. The plant handled machining and assembly of major engine components, such as crankcases, cylinder heads, crankshafts, and connecting rods, for these engines as part of the integrated Mercedes-Benz powertrain production system in Germany. Untertürkheim has a long tradition of four-cylinder engine production, dating back decades, including major petrol and diesel units that powered many Mercedes models. Early post-war four-cylinder engines were built here, and by the 1990s, large-volume four-valve four-cylinder units like the M111 engines were produced on site for a range of vehicles. In the late 2000s, new generation four-cylinder diesel engines went into series production at Untertürkheim, with significant investment in machining and assembly facilities for crankcases, cylinder heads, and core components. Today, Untertürkheim remains an important center of engine and powertrain production, but the site is also evolving with continuing production of electric drive units and future propulsion technologies as Mercedes transitions toward electrification. Last year, the Mercedes-Benz Untertürkheim plant employed approximately 16,700 people. These factory workers in Mercedes t-shirts are working on crankshafts, pistons, and camshafts, which are meticulously installed. Robots handle the precise insertion of pistons and bearings, while human technicians oversee delicate tasks like timing chain installation and fine lubrication. Robotic arms and automated torque tools ensure that all bolts and fasteners meet exact specifications every time. Cylinder heads with their intricate valve trains are assembled and tested separately before mounting. Camshafts, valves, and timing components are calibrated and aligned using sensors and digital measurement systems. Once installed on the engine block, the cylinder heads undergo tightening and leak testing to ensure perfection. The engine is then completed with ancillaries including turbochargers if applicable, fuel injection systems, water pumps, and electronics. Each engine is bench tested under simulated conditions for power, efficiency, and durability, with advanced testing rigs capable of simulating thousands of kilometers of operation in just hours, detecting even the smallest irregularities. Right now, you're watching famous German engine builder Michael Mittler hand-assemble this powerful and expensive AMG inline 4 engine. Mercedes employs several dozen specialized technicians like Michael, and each of them assembles several engines per week. In 1 year, a single technician can assemble up to 200 engines. This is the process of manufacturing the Mercedes-AMG M139 engine, a 2.0-liter engine with 420 horsepower. These M139 engines are installed in models like the Mercedes A45, CLA45, or C43. Unlike AMG V8 engines, which are produced in several thousand units per year, the M139 engines are made in much smaller numbers annually. Unlike mass-produced engines, these inline-4 engines are built at a single workstation. The engine stays in one place while the worker brings all the tools and parts to it. The Mercedes-AMG M139 engine is a true masterpiece of modern performance engineering. With its 2.0-liter turbocharged four-cylinder design, it currently holds the title of the most powerful production engine of its kind in the world, delivering astonishing power and precision for a compact sports engine. What you are watching right now is the core idea behind the production of these powerful engines called one man, one engine. This philosophy means that each engine is assembled from start to finish by a single AMG technician, whose name is proudly displayed on a plaque atop the engine. Each of these engines is built at the engine plant in Falterbach, Germany. The plant produces some of the most powerful engines, including V8S, V6S, and the legendary M139 inline-4. These engines are built exclusively for high-performance models. Despite being hand-built, the plant uses modern technology to support assembly, precision measurement tools, engine testing rigs, and special lifting systems. The training of this muscular worker in the black shirt is intensive, often taking years to master the high standards of AMG. The facility is designed according to Industry 4.0 principles, featuring smart manufacturing, digital support systems, and modular workstations. Some engines from a Falterbach factory are so rare that only a few thousand are made per year, especially AMG V8s. Meanwhile, the M139 inline-4, while more common, is still a hand-built, high-performance marvels. Precision tools and sensors guarantee that all torque settings are exact, while each engine undergoes thorough testing on dynamometers. This process includes leak checks, monitoring of oil pressure, and full performance runs to ensure the engine meets the highest standards before leaving the facility. Right now, you're watching the precise assembly of the crankshaft inside the engine. Forged from high-strength steel, this crankshaft is built to withstand extreme RPMs. Thanks to careful calibration and hardening, it can handle engine speeds of over 7,200 revolutions per minute in the S version. Its shape is optimized to reduce rotational losses and vibrations, which is especially important for a high-performance four-cylinder engine. The crankshaft is made of forged steel for low inertia, the pistons are forged aluminum for strength, and the connecting rods are forged to make a strong but lightweight engine. The twin-scroll turbocharger has roller bearings to reduce friction, an electronically controlled wastegate, and can reach a maximum turbine speed of about 160,000 revolutions per minute. The engine has two separate cooling circuits for the head and crankcase, an electric water pump that cools the block independently of engine speed, and a liquid-to-air charge air cooler for high thermal efficiency. The cylinder walls are coated with nanoslide, which reduces friction, improves durability, and helps manage heat. With a specific output of 210 horsepower per liter, this engine ranks among the highest in automotive history for production cars. So the one-man, one-engine principle means that each AMG engine is built start to finish by a single highly trained technician. That technician is personally responsible for the full assembly of the engine, not just a single task on a conveyor line. The tools include digitally monitored, torque-controlled wrenches to ensure every part is installed perfectly. Each technician is personally responsible for the quality of their engine, creating a strong sense of pride and accountability that helps deliver higher reliability and performance. After the assembly of each M139 engine, a metal plaque is attached to the top of the engine cover, proudly displaying the name and signature of the technician who built it. This is more than just a badge. It is a symbol of the craftsmanship, precision, and care that goes into every engine. Each plaque represents the human skill behind the technology, highlighting the tradition of hand-built performance engines. It is a visible reminder that behind the extreme power and advanced engineering of the M139, there's a personal touch, pride, and accountability in every detail. Human craftsmanship ensures personalized attention to every engine. Quality control reduces errors and maintains high consistency. Brand heritage reinforces AMG's racing and performance roots. Customer connection makes each engine feel unique and special. Right now you are watching how dual overhead camshafts are assembled. The camshafts are made of hardened steel and have precise shapes to control the valves at very high RPM. Both the intake and exhaust camshafts use Camtronic variable timing, which changes how the valves open and close. This helps the engine have more torque at low speeds, better fuel efficiency, and smoother power delivery. It also reduces turbo lag, which is important for a powerful small engine like the M139. The camshafts are also lightweight, which helps the engine spin faster, and they are strong enough to handle high pressure and high RPM. Combined with the light valve train, aluminum pistons, and forged connecting rods, this allows the engine to rev freely while staying reliable. Throughout the video, you can see that AGV vehicles are often used to transport the engines. These vehicles are programmed to carry engines across the factory floor. AGV help reduce the need for manual handling, ensuring that heavy engines are moved precisely without risk of damage. They follow predetermined paths, coordinate with workers and equipment, and keep the assembly line running smoothly. Even though each engine is hand-built by a single technician, AGVs make the logistics behind the production seamless, allowing technicians to focus entirely on assembly. This combination of human craftsmanship and smart automation is a key part of AMG's approach to high-performance engine production. Pride and accountability motivate technicians to deliver perfection. Engines with this philosophy include the 2.0-liter inline-4, 4-liter V8 biturbo, and V12 biturbo used in AMG and Maybach models. The one-man, one-engine approach is a core part of AMG's heritage, blending advanced manufacturing with skilled craftsmanship. The average time is 3 to 4 hours, covering component preparation, full manual assembly, torque verification, digital logging of build steps, and leak testing with inspection. Technicians often build only 1 or 2 engines per day depending on model. Even though it takes hours to build one engine, AMG could automate it, but they intentionally don't. Affalterbach is where AMG transformed from a two-man tuning shop in 1967 to a world-famous performance division. Mercedes-AMG started full operations under Daimler-Benz in 1999, but Affalterbach has always been its spiritual home. The AMG engine plant in Affalterbach employs around 200 to 300 people, including engine builders, support staff, and management. This is how the Mercedes-AMG 63 V8 engine is manufactured. Each AMG V8 is hand-assembled by a single master engine builder. Unlike mass-produced engines, AMG V8 engines are built at one workstation. The engine stays in one place, and the worker brings all the tools and parts to it. Compared to regular Mercedes engines, AMG 63 V8 production is very limited, with each builder producing only a few engines per day, and some assembling fewer than 200 engines per year. This low output is why AMG V8s are increasingly rare and expensive. Built at AMG Affalterbach, Germany, in a climate-controlled clean assembly hall. Bearing clearances, piston tolerances, and crankshaft alignment are measured to micron-level precision. Each part is measured multiple times during assembly, not just pre-assembly. Parts are often select fit, rather than interchangeable. Two identical engines may use slightly different bearing shells or piston grades to achieve perfect balance. Modern AMG 63 V8 engines use a closed-deck aluminum block, an uncommon choice in mass production that significantly strengthens the cylinder walls and allows the engine to withstand extremely high turbocharged cylinder pressures. This design also provides exceptional tuning headroom, with well over 700 horsepower achievable on stock. Every AMG 63 V8 is equipped with a forged steel crankshaft, forged aluminum pistons, and forged connecting rods. Many high-performance engines in the same price class still use cast components. Forging allows higher RPM, higher boost, and greater durability under thermal stress. The crankshaft, pistons, and rods are balanced as a matched set. Even the flywheel and harmonic damper are selected and verified per engine. The engine is balanced not only mechanically, but also thermally, accounting for expansion at operating temperature. This is more typical of race engines than street engines. Unlike mass production engines, AMG V8 are assembled at stationary workbenches, with the engine remaining in place while tools and components are brought to the builder. This approach reduces assembly stress, minimizes human error, and ensures greater consistency between engines. Heads are CNC machined for precision, with critical areas like valve seats and ports hand-finished. Valve clearances are set manually, and camshafts are installed and timed by hand. AMG prioritizes consistency over speed, even if it lowers production volume. The AMG 63 V8 engine powers a range of high-performance Mercedes models across sedans, coupes, SUVs, and GTs. It is found in vehicles like the E63, CLS 63, and S63, as well as their coupe variants. Among SUVs, it is used in the GLE 63, GLS 63, and the G63, while the AMG GT 63 and GT 63S 4-door coupe also feature this engine. Different models may use specific variants of the 4.0-liter biturbo V8, depending on the application. Many AMG engine builders have 10 to 30 years of experience, were trained by earlier AMG masters, and often specialize exclusively in V8 engines. AMG treats engine building as a craft rather than a routine job rotation. Mercedes-AMG employs about 50 dedicated master engine builders who hand-assemble AMG engines. Each builder signs their work with an engraved plaque under the one man, one engine philosophy. These builders form a highly specialized, relatively small team working within AMG's Affalterbach production facility. Each one is responsible for assembling an engine completely by hand, starting from a bare engine block and continuing through to full completion. Once the engine is fully assembled and passes all inspections, it is finished with a distinctive metal plaque bearing the name of the builder who created it. This signature is more than just a formality. It represents personal ownership of the engine's quality and performance. Because of this system, each engine is fully traceable. If any issue ever arises later on, AMG can identify exactly which technician built the engine and review the specific assembly process it went through, ensuring complete transparency and accountability from start to finish. This is how Mercedes-AMG 5.8 engines, the renowned 4.0-liter twin-turbo 63 power units, are built entirely by hand. Right now, you're watching German engine builder Janik Stahl carefully hand-assemble one of these high-performance and extremely valuable engines inside AMG's Affalterbach facility. He is one of a small group of specially trained technicians entrusted with building AMG's V8 engines, including the 4.0-liter twin-turbocharged unit used in performance models such as the AMG GT, G63, and S63. These engines are known for their precision engineering, immense power output, and strict quality standards. As part of the famous one-man, one-engine philosophy, Janik completes the entire assembly process himself. That includes fitting the pistons, precisely torquing the cylinder heads, installing the turbochargers, and carrying out multiple detailed measurements and checks throughout the build. Every step requires absolute accuracy, as even the smallest deviation can affect performance and reliability. He and the other technicians like him are part of an elite, highly skilled group of craftsmen chosen specifically for this role. Together, they are responsible for producing AMG's most iconic engines, each one individually built, tested, and signed off by the person who created it. Janik Stahl personally performs the entire assembly of a V8 engine, from installing pistons to torquing the heads and finalizing the build. After assembly, he affixes the signature plaque bearing his name onto every engine he completes. It reinforces the idea of AMG as a performance brand with a human touch, distinct from fully automated engine production in the broader Mercedes-Benz group. Right now, you're watching him carefully install all 8 pistons into the engine. AMG V8 engines, including the 4.0-liter twin-turbo 63 series, use forged aluminum pistons. These pistons are specially designed to withstand high cylinder pressures from twin turbocharging, operate at high RPMs, and endure extreme thermal loads. The forged construction provides greater strength and durability compared to standard cast pistons. This allows AMG engines to handle both factory performance and extensive tuning without internal upgrades. AMG engines are validated for sustained high-speed autobahn runs, track abuse, extreme hot and cold temperatures, and long oil change intervals without damage. This rigorous testing is why stock AMG engines tolerate tuning so well. As AMG transitions toward 4-cylinder hybrids and electrification, the AMG 63 V8 stands out as one of the last hand-built high-displacement performance engines and a direct descendant of Mercedes motorsport engineering. Among SUVs, it is used in the GLE 63, GLS 63, and the G63, while the AMG GT 63 and GT 63S 4-door coupe also feature this engine. Different models may use specific variants of the 4.0-liter biturbo V8 depending on the application. This crankshaft is the beating heart of an AMG V8 engine, and its manufacturing and finishing reflect race-level engineering. AMG V8 engines never use cast crankshafts, they are fully forged. The crankshaft is made from high-strength steel alloys, often microalloyed chromium molybdenum steel. Forging aligns the metal's grain structure, making it stronger and more resistant to fatigue. This is crucial for withstanding high boost pressures, high RPM loads, up to around 7,000 RPM in some AMG GT variants, and extreme torque spikes. Even though the forging is done industrially, the finishing is highly manual, with critical grinding and polishing done by hand or with hand-guided machines. AMG doesn't just balance the crankshaft on its own. Each crankshaft is dynamically balanced with its matched set of pistons, rods, and flywheel. Small counterweights are sometimes adjusted manually, and some engines even have micro-drilled counterweights to achieve perfect rotational balance. The builder may use click-type torque wrenches for tactile feedback, or electronic torque wrenches for precise readings down to 1 Newton meter. The engine builder personally torques all critical fasteners, including cylinder head bolts, main bearing caps, and connecting rod bolts. Even bolts of the same nominal size might require slightly different torque angles to account for material expansion, bearing tolerances, or cylinder head flatness. This manual attention ensures perfect sealing and uniform stress distribution across the engine. Proper bolt torque prevents head gasket leaks, bearing failures, and uneven wear or warping from thermal stress. In AMG V8 engines, which see high boost pressures, up to 1.2 bars, and torques of 900 Newton meters, incorrect torquing could be catastrophic, making the hand assembly process critical. AMG uses a multi-step torque process for critical bolts. The bolt is first hand-threaded, then preliminarily torqued, followed by near-final torque with a precise wrench, and finally tightened to a measured angle to ensure even clamping pressure. This is especially important for cylinder head bolts, which seal the combustion chambers under extreme pressure. It is also critical for main bearing caps, which secure the crankshaft under high torque. Many AMG V8 owners love their cars for driving experience, sound, and performance, even if they're not perfectly trouble-free. Owner satisfaction surveys, not just enthusiast forums, generally show high enjoyment and strong performance ratings. Highly engaging and emotional engine, but not bulletproof. Many owners loved the character, but issues were reported as vehicles aged. Cylinder head bolt failures were famously problematic on early cars and could lead to expensive repairs. Oil consumption and leaks are commonly mentioned by owners, sometimes requiring more frequent top-ups or checks. Drivability, soundtrack, and performance rarely disappoint. Many owners wouldn't trade the engine feel for anything else. Small oil leaks or pressure drops often trigger chain wear or misfires first. Owners think engine failure, but the root cause is often gasket degradation or oil starvation during cold start. A lesser-known point is that low-load driving can sometimes be harder on AMG engines than spirited driving, because combustion chamber deposits tend to build up more quickly, and components like turbo wastegates and injectors don't operate through their full range as often, which can reduce their efficiency over time. A hidden pattern is that many reported failures tend to cluster in specific production batches or regions, or among owners who use the wrong oil specification or extend service intervals beyond what's recommended. This can create the impression that certain engines are inherently unreliable, when in reality the issues are often driven by differences in maintenance practices and usage conditions rather than the engine design itself. Some owners strongly caution about engine and transmission issues, especially in high mileage or hard-driven cars. Right now, you're watching Janik Stahl attach the plaque with his name and complete his work. Now the almost finished engine is moved to the testing department inside this German factory. The AMG 63 V8 has been continuously developed for over 20 years, evolving from a naturally aspirated engine into a highly efficient twin-turbo powerhouse. Once finished, the engine is tested, cold start/dyno check, and then forwarded to be installed in whichever AMG model it is destined for. This engine must pass several dozen testing points on the checklist. Now the engine will be run on this dynamometer at maximum power, and its overheating and stability will be monitored.